Hi, everyone. I hope you're able to solve or at least try the problem I shared with you in part one of this series, and welcome to part two. Um, I'm very excited and hope you are learning as well with me on how to use Python to build your momentum portfolio. And before I get into how to solve that problem, let me recap it quickly for you. So at the end of part one, we got this as an output. For each date, we have the share price for both Tata Motors and Polycab. But what we want is the Friday data instead alone. And for a specific week, we want one data point. If Friday is not available for some reason because it's a holiday or some sort, then then we have to pick Thursday automatically. And if Thursday is not available, then Wednesday and so on. So how do we do that through code is something that we'll look at today. And we will also eventually get the stocks that are in momentum. So let's jump right into it. Please do not consider this as an investment or trading advice. Please do your own analysis and research independently before you make a sound decision. Okay, so if you remember in our Excel file, we've got the share price for Tata Motors, and we used weekly here, and weekly essentially gives us the Friday close price. But if you try to use week here, there is a way to also change the interval in Yahoo Finance to use or get the granularity by week, but that gives you Monday close data. But let's try to match it up with Google Finance because that helps us validate our data. Now, what I would do is quickly add a code cell to this, and I'll try to do something interesting here. So first, I'll start with adding a week start date. And this is how I'll do it. Stock data week start date is equal to stock data date minus time delta stock data date day of the week unit equal to 2. So what essentially this does is we are creating a week start date by using the date column that is already present in our stock data, and we are taking this date back to Monday. So if I quickly run this, I think you're going to witness this and play this. What will happen is you will see week start date here, and this is nothing but a Monday. Or for every day that is there here, we're going to have a corresponding start of the week here. Now, why am I doing this is something that you will know in a bit. So just hold with me on that. The next thing that we're going to do is calculating the weekday number. So the way I'm going to do that is, add weekday number as a new column, and just similar to using day of week here, we use weekday function here, and that will add the weekday number in the data for us. So how will this look like? So you have 0, 1, 2, 3, and 4, and so on. So this is a Monday. So Monday starts with 0, then Tuesday starts with 1, and so on and so forth. Now, I'm going to get the max weekday for every week, right? If you remember, I'm trying to get the Friday close data. So obviously, Friday will be the highest weekday number, and if Friday is not available, then it takes Thursday as the highest weekday number. So let me try to get that using a new data frame. So I do a group by. So group by is essentially taking a specific set of variables and doing an aggregation on another variable. So I'm using symbol and week start date as my group by variables. And I'm performing this aggregation, which is max, on the weekday number. So what will this do is it will give me the max weekday number for every week. Let me remove this for a bit and run this. So when I look at grouped data frame, it shows me that, here for every week start date, I got the week max weekday number. Now, if you see this, polycab is not repeating because it's not a data frame anymore. That's what some of these functions do. So we need to reset the index, and we can do that in the same line, and we need not create another line here. So I run this, and here you see it's in a data frame, so that we can very clearly use this for further operations. Now, once I got the max weekday number, I'm going to join this with the original table, which is our stock data, because we don't have price data here anymore. What we got is for every week, what is the weekday number that we should look at. Now I will join with the original table on week start date and weekday number to get the price as well. How am I going to do that is through a join. And we can simply use an inner join here. So two tables can be joined on specific set of variables. Here my variables are symbol, week start date, and weekday number. And there are multiple ways to join two tables. One way is inner join. So let me run this. I'm going to put this output into a new data set called Friday close data. And when I run this, I'm going to see the result along with the close price. And not just the close price, I also got open, high, low, all the other variables that we had originally in the stock data set. But in this data set, we just got one data point for every week. So notice that you don't have every day's data, but just the Friday's data. At this point, let's see if we can compare this with what we got in Google Finance and see if we get the exact same number. So on 9th June, the close data sees 562.29, which is roughly the same here, 562.3. And on the next week, it is 569.79. And here I see 569.8. So we got the Friday data for both Tata Motors and Polycab. Now, let me add a new code cell here. We got the Friday close data. Now we have to do what we have to do here, if you remember, is we have to compare this cell with the cell that is 4 weeks ago. So we need to get the share price that is 4 weeks behind every week. Now, how can we do that is something that we'll look at. So first we can add a new variable called 4 weeks ago. Essentially what that means is, I'm trying to go 4 weeks behind from the week start date. Now you'll see how am I going to use this shortly, but let me add an output here so that you can visually see what's happening here. So I'm going 4 weeks from the week start date, and that's what is displayed in this variable. Now, this is not enough. I need to get the share price for this specific week. Now, what we can do to get the share price, like what we did earlier, we're going to do a join operation. And this time I can do a left join instead of an inner join. I can also do an inner join, but I want to retain some of the columns, some of the values in my left data frame. So I use a left join here. So what I'm trying to do here, if you closely notice, I'm going to merge the Friday close data, and I'm only picking these variables from the Friday close data. I don't need everything. And so joining on these columns, which is on symbol and 4 weeks ago from the left table. And I'm picking symbol and week start date from the right table, and I'm joining on these columns. So when you run this, by the way, I'm putting this data into a new table called momentum data. And when you run this, you see that I got the share price for the week that is 4 weeks behind the existing week. And here you see a few missing values because we don't have share price for the first 4 weeks. So obviously we'll get missing values here. So now we got the current week share price, which is here, and the share price that is 4 weeks ago from the current week. Now, all we have to do is do a mathematical operation between these two share prices, like what we did here, right? So here you can see we measured the percentage growth from 4 weeks ago share price to the existing week share price, and we've added one here. So that's exactly what we are going to do now here as well. How I can do that is simple mathematical operation. I'm going to create a new column called momentum, and I'm going to compare that with 4 weeks ago. So close minus close 4 weeks ago upon close 4 weeks ago, and I'm going to add a 1 to it. When I run this, I'm going to get momentum here starts with 1.099. And if you can see here, it's 110%, which is nothing but 1.09 roughly in decimals. So here we have it in decimals. There in the Google Sheets, we have it in percentages, but essentially it's the same thing. Okay, now we've got this. What we did here, if you remember, was we multiplied all these values. We did a product of these momentum scores and we subtracted one from it. By the way, we've done all of this in part one, so do watch part one if you are not able to understand. So do a product of this. So I can use an aggregate function like what we used earlier. And I'm going to put that into a new variable called mom by ticker, momentum data, group by symbol. So I'm using this as my base. For each symbol, I want the momentum scores to be aggregated, and the aggregate function is product. So if I run this and try to see what's there in momentum by ticker, I see these values. But wait, these don't seem to be in a data frame format. So we need to change this again. So we need to reset the index. But before that, let me subtract one from it so that the calculations match. So we have 8.3 for Tata Motors, and we have 8.3 in the Google Sheets here. So it's exactly matching. But before we use it further, let me try to reset the index. There you go. You see the table again. For both Polycab and Tata Motors, we have the final momentum scores. Similarly, let's create smoothness scores as well for these two stocks. So let me add a new code cell because smoothness calculation is going to be slightly different compared to momentum score calculation, but it's going to be very similar. So if you remember, smoothness, we go 1 week back, right? We subtract each of these values from the previous value. So we're going to do exactly that for momentum. If you remember, we created a column called 4 weeks ago, and we went 4 weeks back. Here, since we are comparing with the previous week's share price, I'm creating a new column called 1 week ago. And let me see how that will look like in the data frame. So along with 4 weeks ago data point, we also have a 1 week ago column. Now, exactly the same way as we did in calculating the momentum score, I'm going to join the momentum data with 1 week ago data point. Let me look at it and see if I'm getting 1 week ago share price. As you can see, the first week obviously is going to be blank. For the second week, I got the share price, which is 562. And if you can see here, 562 is the previous week share price, which I want in the existing week. So I can see 562 as the share price. Cool. Now we have got the week ago share price. All we have to do is a simple mathematical operation to calculate smoothness. So I calculate smoothness for every week. and I get the smoothness scores, and we are not done yet. By the way, we just got a difference between share prices. We would still need to aggregate the smoothness scores. Like if you remember in the momentum uh, demo Google Sheet, we've calculated the number of positive weeks, which are 32, and the total number of weeks, which are 46, right? So how do we get that 32 number is what I'm going to show you now. So let me add a code cell here, and I'm creating this new variable called smoothness by ticker, and I'm using the above data set group by the symbol, and I'm using a function here which is called a lambda function, which is a function that you can quickly write here. See how many positives do we have in the smoothness column divided by length of x minus 1. I'm doing -1 here because if you see here, there are a total of 46 weeks here, and the first week is empty. So I don't want to calculate or use that measurement. So I'm going to subtract -1 from that. So if you see the output here, you can see for both Polycab and Tata Motors, you can see the smoothness scores. So let me compare this with what we get in the Google Sheets, 0.617 and zero point 0.7, and 0.7 is the smoothness score for Tata Motors, and this exactly matches with what we got through the code. Perfect. Now we've got both momentum scores and smoothness scores, but we want both of them in the same table so we can do the operations on all the stocks at once, and we don't need to use two different tables. So let me combine them through this simple merge function again, like what we've been doing so far. I have momentum scores in momentum by ticker data set, and I have smoothness scores in smoothness by ticker data set, and I'm using an inner join to combine these two. Now let me see if I'm successful here. If I run this, you can see perfect. I have Polycab, the momentum score, and the smoothness scores. I have Tata Motors, the momentum score, and the smoothness scores. And let me quickly compare. 8.3 is the momentum score, and 0.7 is the smoothness score. 8.3 and 0.7 in my Google Sheets as well. So perfect. So we got both the scores. And by the way, we also got it for Polycab just through a code. And let me show you how this works, right? So if I simply add here Reliance, and you have an option here to run all the code cells at once. So you run all, and you just scroll down. There you go, right? You see momentum and smoothness scores for Reliance already captured here. And if you have to do this in a Google Sheet, it's going to be a lengthy process for sure. As a bonus, I'm going to show you how you can further scale this through code. So far, we have added 3 stocks here, Tata Motors, Polycab, and Reliance to your tickers variable. But if I had to add 750 stocks here, which are part of the Nifty Total Market Index, I can't add this manually here. It's going to be clumsy for sure. So instead of adding them one by one here, let me show you how I can do that. So there is this website, nseindia.com, and here in this specific URL, you can actually download the list of stocks that are part of the Nifty Total Market Index. So when you click on this, it will download a file for you in your local drive. What you can do after that is you can upload this into your local Google Drive. So here, I've already uploaded this into a local Google Drive here. And when I open this file, I've already opened this for you. You can see these a list of stocks here. You can see the company name, industry, symbol, series, ISIN code. But what you are really interested in is the symbol. So this is what you will essentially use to download data from Yahoo Finance. But how do we access this file that is already on your Google Drive through code? Now, one way to do that is adding a library which can access your Google Drive from Google Colab. So let me add that piece of code here. Google Colab import drive. So I am from this module, I am using drive class, and I'm mounting this drive through this code. So when I run this for the first time, what will it do is it will ask me a permission to connect to the Google Drive. You can click on this, and it will quickly ask you to also sign into the Google account. So you can quickly accept all of them, and this part of the code will run. And as you can see here, this ran in 33 seconds. And now you're able to access your Google Drive from your Colab notebook. And since we're going to define a new list of stocks into this stickers variable, I'm going to remove this and define that through a new code cell here. So for me to read the stocks, I use a function called read_CSV. This is again a function that is available with pandas, and add that to tickers, which we've been using earlier. And here you can see I have defined a path. So in my drive, in my Google Drive, I've added this file, the Nifty total market index or list of stocks, into my momentum folder, and I can read them through this function. So when I run this, you can see all of these stocks are already part of this variable. But Yahoo Finance cannot use these symbols as is. And if you remember, we've added .ns to the symbol. So before we can use these symbols to download the respective stock data, we need to add .ns to it. Now, how can I do that? I can simply concatenate .ns to it. So here is the function I would use. I'm creating a new variable called ns symbol, and I'm adding .ns to it. So when you run this, you can see a new variable called ns symbol, and .ns is now part of that. Now I can use this specific column or the stocks that are present in this specific column to download the data. But the code doesn't know that. It's still accessing tickers, but not specifically that column. So I can define that column. And here you can see Google Colab is automatically showing the variables that are part of tickers. So you can directly take that. So when you run this, so here each line essentially means it's downloading one stock. So this will run about 750 times. So it's going to take some time. Not very long, probably take about a couple of minutes to run this. Okay, this is completed running. And as you can see here, it took roughly about a minute to complete downloading all the stocks in the Nifty market universe. So that is roughly about 750 stocks, and it indeed ran about 750 times. And here you can see it starting from 361 symbol to eMudra. All the stocks and their respective data is being downloaded. And I will also now run all the other code cells using this option here. But I want to see the momentum and smoothness in an Excel file. I can also do that by pushing this data into the Google Drive, back into the Google Drive. So if you see the last code block here, you have the momentum and smoothness scores for all the stocks here. But I want to put this data in Google Drive. I can do that pretty easily. Let me quickly add a code cell here, and you can use this function which converts the existing table into an Excel file. So if you see the last table coming out of this entire code is momentum smooth by ticker. So I am converting that into an Excel file, and I'm putting this in a specific path in my Google Drive. Again, I'm putting this in a folder called momentum by the name momentum smooth by ticker with an extension of Excel SX. Index is false is essentially I don't want the index to be exported as well. So I can just quickly run this, and this will put this data into my Google Drive. And I have opened this tab already. So you can see here all the momentum and smoothness scores for about 750 stocks. There you go, about 750 of them, all of them from the Nifty universe. Okay, so this is the power of code. You can simply scale your strategy by using code. You can get all these scores for all the stocks within no time. But if you have to do this in Google Sheets, it's going to be quite some task for you. It's going to be clumsy. It's going to be a tough task for you. Now, one approach investors use, but particularly momentum investors, is using these scores to further filter down the stocks. So depending on the portfolio size that you want to have, and depending on the rebalancing frequency, be it monthly or weekly or bi-weekly, you run that you run this code on a regular basis. You get this list of stocks, and one way of filtering the stocks is, you can pick the top 25 percentile in terms of the momentum scores, and you sort them by smoothness. So that ways you know which stocks to pick. So you're picking both based on quantity as well as quality by using both of these scores. So that's all from me. In this two-part series, I've covered a sample strategy that we picked from a book and showed you how to use code to download this data at scale. I hope you find this useful, and thank you so much for watching this.